All right, folks, welcome to week 2, module 2, analytic applications and introduction to spreadsheets and databases. So depending on the organization you are working within, the data analysis project or research question you are tackling may have broad macro impacts affecting entire populations and economies, or highly localized and nuanced ones impacting only a handful of people. Descriptive analytics asks that question of what happened. Diagnostics addresses the next logical one of why did this happen. Predictive analytics is really about what might happen in the future based on this. And prescriptive analytics looks at what comes next as our best course of action. Developing a structured approach to problem solving provides a framework on which we can critically examine our research questions. This is an application of deductive and inductive reasoning techniques. It's a lifelong process of working to identify and challenge our assumptions and disrupt our unconscious biases. Inevitably, as a new data analyst, engineer, or scientist, you will need to become competent with data cleaning and preparation methods. Depending on where you're performing this data cleaning, it could include anything from sorting and filtering data to standardizing, deduplication, and beyond. No one will ever care how many hours you spent coding that problem. They just want their data and they want it fast. So when undertaking a new role, spend time in the documentation. Hopefully you are greeted by an onboarding document that provides you a well-articulated system of business rules, a data model, and a data dictionary. You might also be building these products from scratch yourself or coding without real access or visibility into the data. There are many sources of information out in the world to assist you. Some organizations like the World Bank or federal government publish massive archives of data. In other places, the data is virtually non-existent and measurement proposes unique risks. Data cleaning could be scripted through software and is hopefully well documented with code that captures business rules in the cleaning and preparation process. In this class, we'll utilize a handful of those tools to help us utilize and visualize and explore data analysis, which is itself a blend of art, communication, and science. Quantitative analysis uses mathematical and statistical modeling to measure and research, understand relationships and behavior. It can encompass everything from predictive modeling to regression analysis that looks at the relationship between variables in the data. Qualitative analysis, on the other hand, is better for thematic mapping. The analysis of content can be used to examine free-form structured data, as well as such things that are not really measurable, such as our name or our ethnicity. Qualitative data is either nominal, such as categories that may be gender, religion, ethnicity, or ordinal in nature, such as high, medium, or low, or first, second, third. Quantitative data, on the other hand, can be discrete, such as the number of students in this class can either be 1, 2, or 3. It can't be 1.5 or 2.5. Or continuous, such as the height of my child or the speed that my motorcycle drives at. Generally, once we have our data in hand and it's been cleaned, we feel confident in its provenance and veracity, we're going to begin that exploratory data analysis process, which is generating descriptive statistics about our information. We can use pivot tables to do this and quickly summarize our data if it's not too large, or we might be using advanced functions for statistical analysis. We can also do some modeling and what-if scenarios, and there's a wealth of AI and ML tools out there on the market right now that can do a whole bunch of cool things with your data, some of which we'll explore in this class. Storytelling with data is an integral part of the skill set required by any analyst. Crafting effective data visualizations and reports is as much about considering what to do as what not to do. Remember that when presenting analytical insights to diverse audiences, spend some time to consider the unique cultural and social values of the individuals who will be receiving your presentation. So we've talked a lot generally about data. Let's spend some time discussing the differences between spreadsheets and databases quickly. Again, spreadsheets are great for many use cases. However, when we move into production at scale, there are some limitations that make databases the more attractive option. Think of it this way. Spreadsheets allow you to utilize data from multiple repositories, importing it from a diversity of sources, and then structuring and formatting that information in different ways to utilize it efficiently in your research and application. The ability to effectively utilize spreadsheets to conduct analytics is naturally related to how we visualize and plot that information. As part of this course, we will explore tools and programming techniques that can be used to create rich visual representations of our data, like this, for example. Data visualization is a process of creating charts and graphs that visually represent our raw information. Choosing appropriate chart types based on data characteristics enhances the visualizations. And the interactivity pieces that you can build in with new tools and software allow for dashboarding and just really engaging content across a number of mediums. There are even visualizations out there that provide us with a visual vocabulary for understanding the different chart types for representing our data, such as this visual vocabulary, which I definitely suggest you check out. Thanks in part to their wide use and development over the years, spreadsheets, programs both from Microsoft Office and Google, as well as some open source versions, allow for a lot more collaboration and version control now to assist with data integrity. Gone are the days where we had to check a spreadsheet out and wait for someone else to check it back into SharePoint before we could complete our day's work. All of this means that sharing and collaboration on spreadsheets with team members is easier to address. However, we also still have that fat-fingered data error problem in spreadsheets, which might require some protection and locking of our data in spreadsheet format when we're working with it. Please keep in mind, whether you're working in spreadsheets or a database, that becoming efficient and not just querying and thinking about problems critically, but also automating that scripting is really a critical skill set for folks going into this field now, especially as some of that exploratory data analysis and initial predictive modeling can really be handled by a few of those off-the-shelf ML tools that are now available in many product suites in cloud production environments like Google and Amazon. So there's an adage in the AI and machine learning data science industry that says garbage in, garbage out. Effectively, your insights and answers are only as good as the quality and reliability of the data on which your analysis is being conducted. What may work great as an ad hoc query could be entirely inefficient as part of a production pipeline. So think of a spreadsheet as the foundation of a database. It may be even one artifact or input of it, and can be really great in the utilization of your daily work. Databases are everywhere, and the reality is that there are many big names out there. In this class, we will be developing a SQL-based database. We might dabble a little bit in Snowflake. We're going to talk about MongoDB databases because they are increasingly being used. We'll see a graphic on the next page to speak to that. And then we'll also do some SQL-like development and create a MySQL database in this class. Oracle has been the most popular database consistently over time, but as you can see, Mongo has grown its share of the market quite a bit. There are a number of different database types. Relational databases were most dominant in the 1980s. This is where we have our tables organized into columns and rows that are related. Object-oriented databases allow us to handle documents, images, things like that, whereas distributed databases, you might hear cockroach thrown around, is really multiple different files and bits across and distributed throughout a system. Data warehouses are places where we centrally locate this data. Think of it like a storage unit for your information. A NoSQL database is great for unstructured and semi-structured data. It's really popular for web applications. Graph databases store terms in terms of entities. Google Search is a knowledge graph database. And OLTP databases are databases that have a high uptime, for example, a transactional database for American Express, who processes transactions 24 hours a day, 7 days a week, all around the world. As of April of this year, here's the distribution of market share of major database types. This data is available and published on GitHub as part of a project that looks at different development and scripting environments. Once we've selected our database type, we have to design our schema. There's a lot of different ways in which schemas can be developed. The schema is really a logical orientation of our tables and the relationships between them. It allows us to query and join information across multiple different tables within a database. A well-defined data model and data pipeline are great. Effective storage and management of that information is really an imperative as well. So it is a reality that some computations may require more resources than others. And so thinking about scalability, performance, and data integrity are all parts of a data engineer and database administrator's job. Data modeling and schema design will depend partially on your database type, and it's an integrated process that will include your stakeholders and data producers and consumers who are going to continually shift within your organization. You may find that one company has multiple different types of databases depending on if it is a transactional database, a information management system for lab counts on their lab production yields, or clinical trial databases. It really is going to be dependent on the type of information being stored, how often it's being updated, where it's coming from, so many different factors. In this class, we're going to learn a number of techniques for data extraction and transformation because the ability to effectively query and manipulate information in a way that answers key questions and provides insights adds an immense amount of value to an organization or an individual as an entrepreneur, a student, as a researcher, or a citizen generally seeking to make informed decisions. So once we've identified the data that we're going to be working with, we need to integrate it. This is a process called ETL, data extract, transform, and load. Extraction involves collection of data from various resources. These can be databases, flat files, application systems, social media feeds, or APIs. Once the data has been extracted, we need to transform it. This can be into a consistent format or structure. Before it's loaded into our target system, it might involve deduplication, handling missing values, and combining data from other sources. Data is then loaded in that final step. It might go into a target system or could be loaded to a data warehouse for pickup later or just general availability in a data lake or another data store entirely. Data quality and governance is a large undertaking that requires continual refinement and assessment. Data dictionaries, pipeline flows, refresh cadences, and other business rule requirements are part of building a reliable general data model. And a database in production is often developed and refined in a multi-step stakeholder engagement process. Exploratory data analysis is often the first step in becoming familiar with the data available to you. This can look like ad hoc querying using SQL, some integration with database, visualization, and BI tools, and leveraging existing information to join against. From a diagnostic and productivity or cost-based perspective, we can use data to fine-tune production pipelines and address quality assurance issues. Authentication and authorization mechanisms will vary depending on the sensitivity of the data you are working with and the data privacy and retention policies in place at your company, organization, or agency. These are the first lines of defense to secure data access. Authentication verifies a user's identity, who they are, while authorization determines what level of access or permissions that user should have. Role-based access control, RBAC, is a way of simplifying access control by grouping users with similar permissions needed into roles or categories, and then granting that role access to data. Keep in mind that things are rapidly changing. Staying on top of different providers and solutions, testing out new tools and methods and techniques is one way that you can stay relevant in an ever-evolving marketplace. This week, you will spend some time thinking about the data analysis project you will complete in this class. Over the next coming weeks, we will then explore some real-world examples of data done well and analytics gone wrong. We will also analyze how different organizations have addressed business challenges through analytic thinking and consider the ethical implications of the data we are utilizing and who did or did not consent to be represented within it. That's all for this week, folks. Please make sure you're becoming familiar with our key terms and definitions for the last two modules.